Hello and welcome to helpyourmath.com. In this video, we're going to look at even more examples of graphing reciprocal functions for the parent functions f of x equals 1 over x and f of x equals 1 over x squared. Here's a review of what those two parent functions look like. We want to keep in mind that these are a little bit different than other parent functions we've seen. For one, we have asymptotes. I think this might be the first time we're introduced to asymptotes. So if we have a vertical asymptote, that's a vertical line that the graph will never cross no matter what. We see both of these parent functions have that vertical asymptote at x equals 0. So x equals 0. And what that tells us is that 0 is not in the domain of these functions. So why is 0 not in the domain? Because look, if we plugged in 0, we would have 1 over 0, which is not a real number. So out of the domain, it creates a vertical asymptote. And in previous videos, I've talked about what types of gaps we can have in our domain, what they could be. One is vertical asymptotes. One is we could have a hole at that point. We're only going to focus on the vertical asymptotes. We see they both have that. These graphs also both have a horizontal asymptote at y equals 0. Now, horizontal asymptotes are a little bit different because it turns out that sometimes the graph can cross the horizontal asymptote. Graphs can never cross the vertical. They sometimes can cross the horizontal asymptote. We won't see that in this video. In this video, they are never going to cross either of the asymptotes. We're just looking at transformations of these functions. So applying the transformations of any type of function, that's what we're going to look at in this video. Let's get started with our first example. We want to name the parent function, describe the sequence of transformations, identify the asymptotes, and then we're going to sketch a graph. So what is our parent function? First of all, our parent function, so this is 1, is f of x is equal to 1 over x squared. So remember what that one looked like? It looked like kind of these two things that were identical. They were on either side, nice and symmetric about that vertical asymptote. How is this graph of g going to be different than f? Well, one thing I see is this negative. So we know that it's going to reflect about the x-axis. There's going to be a reflection about the x-axis. So that just tells us that the graph is going to be opening down this time. It's going to look like this and this. And then what else? Oh, here. What's this mean? This means that the whole graph is going to be shifted down 3 units. So the whole thing is going to be shifted down 3 units. That's going to affect our horizontal asymptote, which brings us to part 3. What are the asymptotes? There was no change left or right. So we're going to have a vertical asymptote at x equals 0. And we're going to have a horizontal asymptote. Remember, it got shifted down 3 units. So that horizontal asymptote is going to be down at y equals -3. When we go to graph these, I suggest starting with those asymptotes, get those drawn in. And just keep in mind that the asymptotes are not part of the graph. They just help guide where the graph goes. So I'm going to do them in red to really indicate that these are not part of the graph. I just draw it so that it kind of helps me get the graph as nice as I can. Y equals -3 is going to be down here. And I don't need this to be perfect. For me personally, talk to your instructor if they want it a little bit more precise. I just want the general shape. You know what it's supposed to look like. It's the fact that it's a reciprocal of x squared. And so it's going to kind of hug the asymptote. It'll cross through here and then it'll go down, 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 never crossing either asymptote. This one's going to go down, 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 and it's going to kind of hug at -3. And that would be our graph. Don't feel like you need to be a perfectionist, but usually I'm pretty bad at graphing these. So that's what the graph would really look like. You can tell I was a little bit off base, but you know, it's the right idea. Okay, how about this one here? What's the parent function for this graph? This time the parent function is f of x is equal to 1 over x. What's happening? How is g different than our parent function? So remember what this parent function looks like. We have asymptotes at x equals 0 and y equals 0. We have 1 down here. Ooh, this one's really bad. And 1 up there. Okay, I'm not even going to try to fix it because it's so bad. Okay, describe the sequence of transformation. So how is this graph different? I don't see any negatives here, so we have no reflections, but I do see that there's 1 being subtracted from x. That indicates that we do have a horizontal shift. This graph is shifting 1 unit to the right. 1 unit to the right. And this +1 indicates that the graph is moving up 1 unit. 1 unit up. Okay, so from the parent function, our g is going to be moving to the right and up. That's going to help us figure out where those asymptotes are. So we have one asymptote. We're going to the right, so it's going to be at x equals 1. And we have a horizontal asymptote. It's going to be moved up 1 unit, so it would be y equals 1. Let's start by drawing those asymptotes in. So we have one at x equals 1. That's going to be over here. And y equals 1 will be here. Okay, so just kind of doing a rough sketch of this, I do know that it's going to cross over here and here, just because that 1 unit, if you plug in, I can plug in 0 now, right, because there's a break in the domain now at 1. And if I plug in 0, I would get 1 over -1 plus 1 would be -1 plus 1, which is 0, so I have the point 0, 0 on this graph. And it kind of just, mirrors over here. So I'm going to do this as best I can. Again, these don't need to be super perfect. We just want to show it hugging the axes, or the asymptotes, that is. And again, for the perfectionist out there, I did pretty good that time. I kind of get an A+ for that, don't I? Let's look at another one. First, what's the parent function here? So the parent function is going to be f of x is equal to 1 over x squared. The sequence of transformations, so how is g different than f? Well, I see here we're going to have something going on in that denominator. And if you don't really like using the transformations, you can say, well, I know that x plus 2 cannot equal 0, which means x cannot equal -2. What that indicates to me is that this graph is shifted to the left 2 units. So it's shifted left 2 units. And that's also actually going to help us with our vertical asymptote. And then this +1 indicates to us that the graph is moving up 1 unit. So I'm just going to say up 1 unit. And for our vertical and horizontal asymptote, that vertical asymptote, so I said that x can't equal -2. Making that an equation is the vertical asymptote. So the vertical asymptote is that x is equal to -2, because that's where that graph is never going to cross. It's never going to cross -2. Our horizontal asymptote will be it moved up 1 unit, so it's going to be at y equals 1. Let's start by drawing in those asymptotes. So we're going here, and up 1 at y equals 1. Okay, so there's the setup. Now we're ready to draw the graph. I want to keep in mind this is an x squared, so it kind of goes up. Both sides of this graph will stay above that horizontal asymptote. And I just know that these are going to be points just to kind of guide me. But again, these don't need to be perfect. Kind of like that, and then coming down and hugging that asymptote. I didn't do a graph of this one because I figured I would be so perfect at it. No, really, because you don't have to be perfect at these. We just need that rough idea. Where are the asymptotes? What kind of a graph is this? That's what we're really looking for here. And here's our last example. So we have g of x is equal to -2 over x minus 3 minus 4. The parent function here will be f of x is equal to 1 over x, which usually would have the vertical asymptote at x equals 0 and y equals 0. And we would see the graph appear, and if the asymptotes are defining the quadrants, it would be quadrants 1 and 3. However, with our graph of g, this negative indicates that we have a reflection about the x-axis, which means the graph is going to switch where it is. Reflection about x-axis. So this indicates that instead of quadrants like 1 and 3, that this graph will be in quadrants 2 and 4. Okay, big change. Also, for the first time in this video, we see a numerator besides 1. This indicates that we have a vertical stretch. And we'll talk more about that when we go to graph it, because actually this vertical stretch here really doesn't do a whole lot to the graph. It does just a little bit around the asymptotes, but otherwise not that much. I see the denominator is x minus 3, so this indicates that x minus 3 cannot equal 0, which means x cannot equal 3. This means that where we normally have an asymptote at 0, it's now at 3, so the graph is shifting 3 units to the right. 3 units right. And what else? Last but not least, we have this minus 4, which indicates the graph will be moving down 4 units. So I'm just going to say, and down 4 units. This will help us. These two things right here, 1 and 2, are going to tell us where the asymptotes are. We're going to have a vertical asymptote at x equals 3, and we have a horizontal asymptote at y equals -4. To start these graphs, I'm going to start with those asymptotes. X equals 3 is over here. y equals -4 is down here. Okay, so now let's talk about this vertical stretch. It might help to plug in numbers around the vertical asymptote to get an idea of just how the shift will happen, or the stretch will happen. So let's see, we have x equals 3, so I'm going to plug in 2, no, not to f, I'm going to plug in 2 to g of 2, and that will give me -2 over 2 minus 3 minus 4. Well, 2 minus 3 down here is -1. -2 divided by -1 is 2. 2 minus 4 is -2. So I have 1 point on the graph is 2, -2. 2, -2 is right here. So the graph of f would have a point right here at 2, -3. So we can see it is a little bit more stretchy. We could also plug in 1 just to really kind of hone this in. And again, this is if you want it to be, to kind of see that real change. So g of 1 would be -2 over 1 minus 3 minus 4. This is -2. -2 divided by -2 is 1. And we end up with 1, -3. 1, -3 is down here. Okay, so this graph is going to be here. Ooh, gross. We get the sense of what I was trying to go with there. That's on the left of the vertical asymptote. What about the right of the vertical asymptote? You can plug in points, but again, it doesn't need to be super perfect. It probably looks something like this. And just because there was a stretch and I wanted you to see the difference between the two, here's the actual graphs. The graph of g is in blue, and that orange graph is if the numerator was 1 instead of 2. So I'm going to erase what I did so you can really see the difference. So you'll notice that they're going to level out as they get closer and closer, or the numbers for x get smaller and smaller, or when they get bigger and bigger, you can see that they're going to all kind of converge at those asymptotes. But the big difference is just within here, it's a little bit more stretched than the graph if we just had a 1 in the numerator. These have been examples of sketching reciprocal functions. Thank you so much for stopping by.